Hello everyone, I am Kritika, working as an assistant professor in the Department of Electrical and Electronics Engineering from Shriram in Engineering College, Tirupur. So today's topic is Introduction to Semiconductors. So before we should know what is semiconductors, we should know the basic concepts. So first we should know what is matter. So anything that has mass and occupies space is called matter. So they are made up of very tiny particles called atoms. So these atoms combine to form molecules which makes different materials. Next, the atomic structure. So it consists of protons, neutrons and electrons. The protons are positively charged, neutrons are neutrally charged, and electrons, they revolve around the nucleus and they are negatively charged. So the outermost shell, you call it as a valence shell, and the electrons present in those shells are called as valence electrons. Next, we should know the difference between conductors and insulators. So conductors, these materials allow charges to flow freely. So their properties are, they are highly electrical conductivity, low resistance, large number of free electrons, and good conductors of heat. Next is insulators. These materials resist the free movement of charges. Its properties are very high resistance, poor conductor of electricity, and they prevent leakage current. And examples are, for conductors, copper wire, a silver spoon. Insulators, they do not allow electricity to pass through. So example, rubber balloon, tires, etc. Next, here comes the semiconductors. So semiconductors, they have electrical conductivity between conductors and insulators. So some of the major used semiconductor devices are silicon and germanium. So these are the applications of semiconductors: diodes, transistors, ICs, solar cells, etc. Next, their properties are, they are moderately conductive and the conductivity will increase with temperature. So these components are widely used in electronic devices. So the future is in the hands of semiconductors. Next, energy bands. So we should know what are energy bands. So there are two important energy bands. One is valence band and the other is conduction band. So valence band, they contains valence electrons, whereas conduction band, electrons can conduct electricity. Next, the space between these two is called as forbidden energy gap. Next, the energy bands. How will it change for conductors, insulators and semiconductors? We are going to see. So for conductors, the valence band and conduction band, it will overlap because the electrons can move freely. Next, when you consider insulators, very large forbidden gap. Electrons, they do not move in the conduction band. So therefore, there is no flow of electricity. Next comes semiconductors. So here we will have a small forbidden energy gap. So some electrons gain energy and move to the conduction band. So here the conductivity increases with temperature. So these are the three energy bands. So energy bands for conductors, insulators and semiconductors. Next, types of semiconductors. We have two broad types. One is intrinsic, the other is extrinsic. So the pure form with no impurities, you call it as intrinsic semiconductors. So here the impurity doesn't mean it is not impure. It means we are adding some other material to it. So that is called as impurity here. So in intrinsic we don't add any impurities. Whereas in extrinsic semiconductor we add impurities to it, and that process you call it as doping. So the process of adding impurities to the semiconductors, we call it as doping. In intrinsic semiconductor, there is a low conductivity at room temperature, but whereas extrinsic, it is high conductivity and precisely controlled for electro components. And the number of free electrons will be equal to number of holes in intrinsic, whereas in extrinsic, number of electrons and holes are not equal. So in intrinsic, it relies mostly on temperature, but whereas in extrinsic, it relies on the amount of impurity added. How much impurity we are adding, it depends on that. Next, example of intrinsic is silicon and germanium. Next, for extrinsic, silicon doped with phosphorus or boron. Next is Again, the extrinsic semiconductor is classified into p-type semiconductor and n-type semiconductor material. So it depends upon the doping material added. So when you add trivalent impurity atoms, then it is called as p-type semiconductor. Next, when you add pentavalent impurity atoms, it is called n-type semiconductor. So in p-type semiconductor, the majority carriers are holes, that is positively charged, whereas in n-type it is free electrons. Next, minority charge carriers, here they are electrons in p-type and holes in n-type. Next, impurity type is acceptor atom, it will accept an electron, whereas in n-type it is a donor atom, it will give an electron. Next, energy levels, acceptor level is near the valence band, here donor level is near the valence band. Next, charge, they are electrically neutral, here also it is electrically neutral. So that's all. This is the very basic introduction about semiconductors. Thank you.